in order to try and model what we observe, sometimes the wave model seems to work. And this explains things like refraction and interference. But at other times, we need to think about using the particle model to explain what's going on. And this might be, for example, where we have the photoelectric effect. And so far, what we've looked at is maybe the wave having certain properties which then give particle-like properties as well. So we said E equals HF, or we can look at how the frequency of that wave gives certain photons a certain energy. Now, if a wave can behave as a particle, then surely a particle can also behave like a wave. And this is where this wave-particle duality comes into force. And it was about in 1924 when a scientist was sort of finishing off his work, and as he put his thesis forward, he talked about the wave-like property of certain particles. And his name was Louis de Broglie. Just be aware that his name is pronounced Broglie, not Broglie. Okay, and what he said was that there's for any particle that has momentum, p, it also has a corresponding wavelength. And there's some link between the momentum of the particle, which we give the symbol little p2, and the wavelength. And what he said was that the wavelength of the particle is equal to Planck's constant divided by the momentum. Or we can write this as h over mv. Now the important thing here is that this m here is the relativistic mass of a particle. This means as a particle gets closer to the speed of light, the mass tends to increase due to relativistic effects. And it was in 1927 when this effect was actually shown in the lab. And what they had was a stream of electrons which were emitted by this electron gun, and by firing it through a small piece of graphite, or a small piece of nickel I think they used as well, they could actually use this piece of metal as a diffraction grating. The space between the atoms was so small that it was about the same as the wavelength of the electrons which were going through it. And what they found is that rather than the electrons just going straight through, they found that the electrons interfered with themselves and they formed a diffraction pattern on the end of the tube. And diffraction, because it's due to the interference of waves, is a wave phenomenon. Particles do not behave like this. These ideas from the early part of the 20th century, where sometimes we can think about the particle-like property or the wave-like property, really revolutionised science and brought on the whole kind of quantum physics world. And effectively, it doesn't really make sense, okay? Light isn't just a wave and it isn't just a particle. It's kind of both things at once, but it's not either. And it's very hard to actually try and imagine what this is, because again, the particle model is just the way that we describe things, okay? The electrons aren't all these little round balls going around the nucleus, and neither is light always just behaving like a wave. And it's only really when you have the mathematics that you can actually kind of understand this. I must admit, it doesn't really kind of make sense to me. I can't imagine how something can be both a wave and a particle at the same time. But effectively, we can maybe think about the interaction perhaps of electrons in terms of the particle model. Okay, so these electrons are attracted to positive plates, but when we think about the electrons travelling, this is where we maybe use the wave-like model. And it's because the electrons travel through space as a wave that we then see these electron diffraction patterns, which is something you can actually see in the lab yourself. So I guess this is where the whole quantum physics comes into force, okay, from the work that was done in the early part of the 20th century, okay? Light isn't just a particle, or it isn't just a wave, it's kind of both. And effectively, the intensity of a wave at a point, it represents the probability of a particle being there. And this word probability, the word probability is quite important. Another word done by Heisenberg, by Schrödinger, by Dirac, all these scientists you may have heard of, stems from the work that de Broglie did in about 1924, where he described the particle-like properties, the wave-like properties of things that we'd always until then considered as a particle.